in this lecture we are going to simulate. We are going to first discuss because how to simulate your Verilog code using Xilinx ISE simulator. Again I am saying this is not part of exam as well as the assignment, even you do not need to install the software, but it is just for the interested participant who can actually simulate. So, this lecture is divided into two parts. Part 1 I will be showing some screenshot how to do that, and part 2 will be actually going to Verilog Xilinx ISE software and will actually write some code there. So, here we will first show the step for simulating using Xilinx ISE simulator and some example case study using Xilinx Webpack. So, here once we want to simulate in Xilinx ISE, first of all I am assuming that those who are interested this for optional Xilinx you can actually implement, you can install in your computer, and you can check in the web that how to install Xilinx ISE. So, we are assuming that you have already installed. Now, you can create a project. First steps are this: you need to create a project, then you need to select a device, and we will be showing what device we are going to use for this hardware demonstration, the Xilinx device for this course. Then we will create some module and write some Verilog code, then check the syntax and run the code and the create test bench for a specific Verilog module, and we need to check the syntax and simulate the test bench, and we will to check how to see the waveform using ISIM. So, this is the first. When you install the software, you can see if you go to that, if you click, if you open the software, under the file you will create a new project. Okay. So, in the new project if you go, this is a screenshot, then it will ask for you have to write something. That means you have to select a folder where you want to actually keep this project. So, you can create your own folder, then you have to keep a name of this project. So, here the project name is full adder. Okay. Then you go to the next and do not change anything, this HDL top level should be there. Then next stage it will go for this stage where it will ask for device. So, this thing you do not have to bother, but here in our course we will be using Spartan 6 and particularly device ID is this, that means XC6SL X9 and the package is TQG144, and then you have to specify the preferred language as the Verilog and the simulator ISIM. Okay, there can be model sim, the third party software, but we are just preferring that whatever Xilinx software is there, ISIM, that will be using. Then everything else you keep it as it is by default, only you have to specify the Verilog and the ISIM and this particular device detail. Next, if you go next, it will show the project summary, and then if you finish, if you click this finish, then it will actually create this project. So, that means your new project is created, and the new project will come like a device, this IC. Okay. And this device actually I will go in the next next part 2 to show actually in the Xilinx platform. So, then it will ask for new source, that means it will create like an IC type structure here with a project name. Then in this IC what do you want to implement, because as if you are making an IC, virtual IC which will have number of pins depending upon what exactly you want to implement and how many IO ports are there. Then you have to first add a new source, that means you want to write a Verilog code, new source. Under this source there are many options, schematic, then we have to add the Verilog module, that is it. And if you want to test, there is a test module also there, will come next. So, under Verilog module, this module it will ask the Verilog file name. So, again you are making a full adder as the file name, and it is also under the location of full adder, which is a project name. So, next, remember the file name can be different, I mean it need not to be same as your project name, but whatever file name you will make, the Verilog.v file will be created by that name. So, that you should not change, that means whatever you are doing it should be consistent. Then if you go next, it will ask that how many input output port you want, but I think you do not need to do anything because you will be declaring the port inside the Verilog code. So, you leave it is and then go next. If you go next, then it will ask, it can you will see that your file name is full_adder.v. So, it is a .v file, .v, which is a Verilog file. Verilog extension is .v HDL, okay, and the module name is full adder, okay, and you are also keeping the directory which is D drive in full adder in this case. Now, once it will show. So, this is your project, it will look like an IC here. You can see under this project you are actually plugging one Verilog file which you want to implement like a full adder. You want to implement a full adder. Once you write, by default it will come full adder, and this block you have to specify. That means it is like that module, then it will come like a full_adder. This is the name of the module. Then we need to have brackets, where in the full adder you can specify sum, carry out, whatever you want to write, A, B, then you can say carry in. So, it is up to you whatever you want to keep, but by default, since you have not specified in input output, it will be left vacant. That means there is nothing here, you need to fill the gap, nothing there. So, it is vacant. So, you have to fill this gap, okay. So, you can take this here to like this. Then end module. Now, here you will see the time scale 1 nanosecond, that is if you provide any time unit, 10 unit, 20 unit, it will be in terms of multiplied by 1 nanosecond. That means 20 unit corresponds to 20 nanosecond. And this 1 picosecond slash, suppose if you simulate more precise the decimal, it can go up to 1 picosecond. So, it is more important this value. Okay. Next, now you fill up with your Verilog code. That means if you want to write a full adder, first you can see the sum block. If it is not clearly visible, I am writing here module, then it is the name as the full adder. So, here the module name is again different, because we have full adder.v file, but it is better to maintain the same name rather than naming another name. So, we can use the full adder here, then S, C, A, B, C in. Then we have to define input is A, B, C in, output is S and C. Then we know there are wire connection between S bar, C bar, C2, and then half adder. We need to take call to instantaneous to half adder, and we have to connect accordingly, and then it will go to OR gate to generate the carry out, and then that is the end of the module. Once you write this code, because we have discussed about this Verilog code, then you have to create a new source under this full adder. There you can have a half adder module, because you have called half adder, but you have not yet designed. So, under this half adder you have to create a half adder module name. Again Verilog module name is half adder, it must be same as the module that you have instantiated here. Then again you have to create a half adder.v file, and it will generate this half adder, another module, this sub module, and it comes under this sub module, and you are calling. So, half adder module you have a sum out, carry out A and B. So, you can write in terms of XOR gate, and that we have discussed earlier. So, that means two half adder now are called instantiated, that is why they are coming under one full adder. Once you are done, then you go to implement the top module. In fact, you do not need to implement, because you are not using Verilog FPGA implementation right now. You can end up to synthesis, because synthesis will have RTL block, and beyond the RTL block it will go for implement, where and it will generate actually it will map into the target FPGA device, and finally it will generate the bit file, which I will be showing when you go to hardware demonstration. But here you need to know the RTL logic. So, that means then you can see, that means if you implement, it will show synthesis is done correctly, then translate, then you can see the schematic. There is a tool schematic viewer RTL, and it will show that it is the full adder circuit, which consists of one half adder here, like so. This is, I think, the full adder, and full adder also have an external gate, right. This is half adder 1, this is half adder 2. So, first half adder will take the 2 input and the second half adder take the output of the first half adder and the carry in. Then you can add a new source, you want to test it, go to the Verilog text fixture. That means if you right click here, new source, text fixture. Now what that means, test bench for full adder. So you need to make sure that you are testing the full adder, because the full adder circuit you want to test. You can also selectively test the half adder circuit customizably, no problem. So you have to select which block you want to test, then go, you have to create a test bench, then it will associate with half adder or full adder. So if you make it full adder, then it will create a test bench circuit and it will link. Now in this test bench circuit you can actually make whatever you want, okay. And so that means that's it for the description of how this flow of Verilog. In the next lecture I will be showing the actual Verilog implementation. So in summary, we have discussed step for simulation using Xilinx ISE, and we have also considered example of a full adder circuit, and we will be showing actual Verilog demonstration in the next lecture. That's it for today. Thank you very much. Next lecture